Hello everyone. Now let's come to the final calculation of this particular resistance network, that is RAD. We have already measured and calculated the other parameters, so let's do RAD. We kept this RAD till the end because it involves delta to star transformation, so that's why I kept it to the end. So let's see what it is and we'll try to solve it. So let's go ahead and okay, so here I'll try to solve this part, that is RAD. Now what happens when you try to solve it with RAD is like this. You can just simply see the same circuit can be written like this. See, between B and C we have 560 and 820, two resistances in parallel, so it can be replaced with a equivalent resistance. So I get a circuit something like this. So there is a 220K and there will be an equivalent resistance of 560 and 820, and this is B, C, and here I am having 68K going to D, and I have one resistance like this and one resistance like this. So this is 330K, and this point is A and this point is D, and this is 100K. Now what is this value? 560 and 820. We have already done that before, but then for the sake of practice, let me do it again. Okay? So I just take out my calculator. So here you can see 560 multiplied by 820 divided by 560 plus 820. So that gives me 332.75. Of course, we have done this before. 332.75 kilo ohms. Now the same circuit here, if you try to find more series parallel combinations, you will be stuck at a roadblock. You don't know what. See, these two are not in parallel because after going there, the other end, so here the current is dividing from A, but then these two are not joining back, so in between there is one more resistance. So to know the situation clearly, let's redraw like this. I keep the nodes BC like this and AD like this. So this is in the form of a diamond shape now. Okay, and this is 332.75 kilo ohms, and this one is 220 kilo ohms, and this one is 330 kilo ohms, and this one is 100 kilo ohms, and this one is 68 kilo ohms. So if you observe, these two circuits are exactly the same. Now you can see there are two deltas here. So in order to further solve this problem, one of the delta you can convert into a star, either this one or this one, A, B, C, or B, C, D. One of the deltas you can convert to star. Okay. So let's take the right side one and we'll try to convert this into star. So when we convert this into star connection, so we get something like this. So B, C points are there. This is 220 kilo ohms and this is 330 kilo ohms. Here I get a new resistance and a new star point, and a new resistance and a new star point, and a new resistance and star point. So this is D and this is A. So for the sake of better understanding, let's call this point E. Okay, so we now created an additional node. See, whenever you convert delta to star, you introduce a node, and whenever you convert star to delta, you eliminate a node. Now, but what are the values of these resistances? Okay, so for that we need to quickly refer to some formulas. So I'll just go back here. You can see this is conversion of delta into star. So the delta is like this and star is like this, and this is the formulas that we need to use. Now how did these formulas come? What is the derivation? I already made another video on this. because it will disturb the flow of this video, I am not once again deriving this formula. Let us take this formula as it is and let's work it out. But one thing you should notice is the positioning actually. See, first of all, again, apologies, don't confuse with this ABC with our other ABC in this circuit. So these are different. So the ABC we kept as it is, and in the place of BCD we are doing this calculation. But anyway, so what we should see is the relative positioning. Okay, so for example, if you want this resistance, then what you have to do? So here you can see 2 and 3 are there. So in the formula of RA, these two resistances are coming in the numerator and the sum of all three is coming in the denominator. So this formula we'll use. So R3 multiplied by R2 divided by R3 plus R1 plus R2 plus R3 basically. Similarly, if you want this resistance, then you have to see 1 and 3 you have to multiply and then divide by the sum of all. Okay, so like that. So let me show it here. So it helps if you have the denominator value together. So let's add all these three first. Okay. So what is 100 plus 68 plus 332.75? Okay. So obviously 0.75 will be there, and 8 plus 2 is 0. 1 carries, and then so luckily the number is coming to something easy, 500.75 kilo. So I just added all the three sides, so this will go into the denominator. Now what is this value? It is nothing but 100 multiplied by 68 divided by 500.75. So let me calculate that. So basically I am introducing the formula for calculation. So let's do it here. So 100, in fact I'll just go in a simple calculator mode. 100 multiplied by 68 divided by 500.75. So this gives me 13.58 as the value. So let me write it here. Hopefully it is correct. 13.58. Again, this is in kilo ohms because all the resistances are in kilo. The final value also will come in kilo. What about this resistance? So the two sides of it are 332.75 and 100. Okay, so 332.75 multiplied by 100 divided by this quantity 500.75. So that gives me 66.45. Next, let's calculate the other two, that is 68. So let's clear this. So 68 multiplied by 332.75 divided by 500.75. Okay, so I hope things are clear here. So 45.18. Okay, kilo ohms again. So these are all kilo ohms. Okay. Now let's further simplify this. Now you notice these two are in series and these two are in series. So I get a equivalent circuit something like this. So I'll just draw on this side. So I get 220 and 66.45, and down I get 330 and 45.18. So this is one side, and this point is now E, and I get this 13.58, and this point is D, and then this point is as usual A. Now these two are in series, so let's further simplify this. So let me add that. So 220 plus 66.45 gives me 286.45, and another branch 330 plus 45.18 gives me 375.18 kilo ohms. So now you know what is the next step. Again, simplify this. Two resistances in parallel. So 375.18 multiplied by 286.45, we get some big number. So divided by, now I need the brackets. So 286.45 plus 375.18. So I'm getting 162.43 as the answer. Kilo ohms. This is my final RAD. So this is finally, after doing all these 2 pages of calculations, we come up to this value. So let's see whether it matches with our measured value. Okay. So here I'm getting 162.43, and whereas here it is 175. Okay, so here slightly it's not matching. Let's see how much is the error. Okay, so what do I do? I'll just take 1 by x of this and multiply it with 175. Okay, so this is slightly coming to 1.07. Okay, so the error seems to be 7.7% plus. Okay, so looks like something is not adding up here. Maybe I made a mistake in one of my calculation. So if at all I made a mistake, I'll just correct it in the next video. But for the time being, I have just recorded this, so let this be uploaded, and then if there is any correction, I'll do it in the next video. So finally, before I conclude, we have this circuit, and we try to do all these calculations and find this value. We could have also done one more thing. So instead of converting the right side into the star, I could have converted the left side into star, and I'll get a similar thing. I will also try that, because maybe I'm feeling that somewhere I might have made a calculation mistake and I got this different value. So let's see. So normally, because our error is not there in any of the other values, so if something is there here, error, that might be because of my calculation mistake. So let's see. For the time being, I'll conclude this video here, and we'll correct it in the next video if there is an error. If you find this interesting, please do like and subscribe to my channel. Thank you.